So we are going to talk about vectors, but in space. So first, let's talk about aligning my smartboard. Okay, cross your fingers. There we go. All right. So let's just remember what vectors look like. I tried to earlier. Better? Okay, so remember these alligators, these chevrons is what they're called. That signifies that it is a vector, not a coordinate. Okay, so -1, 2, 4 is there. So our vector will begin at the origin and then stop at that point. So there's our vector lying in octet number 2. Okay. If I said point P is 1, 2, 3, point Q is -2, 0, 5, how would we get vector PQ? Layton says add them. Tyler says distance. Any other ideas? These are coordinates. I just listed 2 coordinates, and I want to know the name of the vector. We actually have to take the difference of the 2, but in a specific order. Which order do we do this? Matt asked, is it P minus Q? Or is it Q minus P? Is it initial minus terminal or terminal minus initial? Changing your tune, terminal minus initial? It is terminal minus initial. I'll even write that for you. Terminal minus initial. Okay. So terminal minus initial, -2 minus 1, 0 minus 2, 5 minus 3. That vector would be -3, -2, 2. If we wanted to plot that one, we could go, what was it, -3, -2, 2? So -3, -2, 2 would be that point. So our vector would go from the origin to that point. Okay. I'm not as worried about you plotting vectors as I am plotting points. Okay. What's going to be more important is what we do here in a little bit with vectors. Okay. Let me remind you of our linear combination form. Do you remember our vectors I and j? Remember how we had our vectors I and j? Well, now that we're in 3 space, vector I is the unit vector 1, 0, 0. Vector j is the vector 0, 1, 0. Now we've added a vector k, the unit vector 0, 0, 1. And so 3, negative 5, 2 is the same vector as 3i minus 5j plus 2k. That is linear combination form. You will need to be able to recognize and write vectors in one form or the other. These are in alphabetical order. Those of you who were upset about the spheres yesterday. Okay, so this vector 3, negative 5, and then 2. There's our vector lying in which octaves? The fourth. Okay, let's see how much we can remember about vectors. What do we call the length of a vector? Its magnitude. Okay. So magnitude is the same thing as length. If we had a vector in 2 dimensions, how did we find its magnitude? The more you help me out, the faster it goes. How did we find the magnitude? You guys just took your final, didn't you? Were there vectors on the final? No? No, they weren't vectors. It does have to do with the Pythagorean theorem. The magnitude of b, the square root of a squared plus b squared, essentially. A squared plus b squared is c squared, yes. Okay, so we take the horizontal component squared plus the vertical component squared and square root it. So if we are in 3 dimensions, how are we going to find the magnitude? Okay, same thing. We're just going to add d3 squared. Okay, so if I want the magnitude of -1, 2, 2, anybody tell you what it is?
3.
It's 3. Lane says 3, pretty confidently. Anyone give him a nod of approval? 3. We take the square root of -1 squared plus 2 squared plus 2 squared. We have 1 plus 4 plus 4, which is 9. Square root of 9 is 3. Awesome. I would like you to complete these 2 operations for me. Remember, when we subtract and add, we just subtract and add like components. If we have a scalar, you multiply all components by that scalar. Okay? So complete these two problems, then turn to your neighbor and check your answers. Morgan, what'd you get for number 1?
1, -7, 5.
Everyone, thumbs up for agree, thumbs down for disagree. Oh, I'm even getting 2 thumbs up. All right, great. Sarah, number 2.
5, 0, 11.
Thumbs up or thumbs down? In the middle if you're not sure. Okay, Matt, what did you get?
Not 221. 221 and the -4.
You got 221, -4. Michael, did you get something different? You got this one? Yes. Okay, so let's all do this together. We have 2 different answers here. So 5B would be 0, 25, -10, right? And 2U would be 2, -4, 6. How many of you did 5U plus 2V? That would be that first answer, right? We should have 2, 21, -4. Details are important. Unit vector. I was throwing out the word unit earlier. What is a unit vector? Okay, a vector with magnitude 1. So if you recall way back to chapter 6, we took a vector and we made a unit vector going in the same direction. Does anybody remember how we did that? Remember how we did that? We multiplied our vector by a number. What number did we multiply our vector by? We want the magnitude to be 1. What did we multiply our vector by? Sarah, what did you say? Did you say something? No? Someone said a word that I like. Did you say something? We multiply our vector by, there it is, 1 over the magnitude. Okay? That way, when you find the magnitude of this product, it's going to be 1. All right? So if our vector is -1, 2, 2. Layton, we already found the magnitude of this vector. What was it? Okay, the magnitude of this vector was 3. So if we want the unit vector, I'm going to call it u, then we would take 1/3 and multiply it to our vector. So our unit vector in the same direction is this. Why are those in the same direction? How do we know that? By looking at them. What's the only difference between v and u? We multiply v by 1/3. Correct. We will talk about this again, but anytime vectors are scalar multiples of each other, they're in the same direction. Okay. So that's why it's still in the same direction. It's because we just multiply it by a scalar. All right. Let's review another operation. Dot product. Okay. If we took the dot product, we took, let's say, v dotted with w. Do you remember that notation? Okay. So v dotted with w. How did we do that? Anybody remember? How did we do the dot product? Yes. You multiply like components and add those products together. Okay. So if we're talking about u dot or v dot w in 3 dimensions, what's going to change? Really nothing. We're just going to add one more component. Okay. We are still going to do the same process of multiplying like components and then adding those products together. Okay. So these are the two vectors I'd like to take the dot product of. I'll give you 60 seconds to see what you can do without me. Josie has -1. Any thumbs up for -1? Okay. We take -1 times 3 plus 2 times 2 plus our z components, 2 times -1. So we have -3 plus 4 minus 2, which is -1. 2 questions for you. First of all, what does it mean if our dot product is 0? Yes, if our dot product is 0, we have orthogonal vectors is what we called it. Let's talk about y. How did we find the angle between vectors? I'm just going to remind you.
Trigonometry.
There was some trigonometry. The angle between vectors, the cosine of theta, is u dot v all over magnitude of u, magnitude of v. So if our dot product is 0, this fraction is 0, and cosine is 0 at 90 degrees. If our dot product is 0, we know that we have orthogonal vectors. Okay? So, let's try this. Okay, so what I'd like, pods 1 and 2, I'm going to have you find me the magnitude of u. Pod 3, find me the magnitude of v. And pods 4 and 5, find me the dot product. That way we can all work together to get these different pieces to find our angle. All right, pods 1 and 2, magnitude of u. Radical 5. Okay. Pod 3. Radical 10. Dot product. 3. Okay. So the cosine of theta, the angle in between these two vectors, is going to be 3 over radical 5 times radical 10. In my opinion, so you do not screw up the denominator, either put parentheses around that or take the inverse cosine of 3 over radical 50. Multiply the denominator together so you don't mess up your order of operations. All right, with your calculators in degree mode, please find me that angle in between. Positive, so should be between 0 and 90. Grant, what do you get?
I rounded it up to 65.
Okay, so like 64.9 is what you had? What Grant got? I see some heads nodding, yeah? Yeah? Okay. So, we decided if dot product is 0, I'm just going to, we're just going to talk about it. If the dot product is 0, we know our vectors are orthogonal. How do we know, or what does it mean if our angle is 0 or 180? Then our vectors are (0 or 180). If the angle between is 0 or 180, that means that they are, we could say parallel, right? They're either going in the same or opposite directions. Okay, opposite directions would be 180, same direction would be 0. Okay, I already hinted at this earlier. Is there another way for us to know, besides finding the angle, that two vectors are going in either the same or opposite directions? Actually, that was about 5 minutes ago. If two vectors are going in same or opposite directions, what's true about the two vectors? How do they look? two vectors are going in the same, we don't really have slope in 3 dimensions. Okay, I don't want to talk about 3-dimensional slope. But if vectors are scalar multiples of each other, that means essentially they have the same slope. Okay? So if I have 1, 1, 1 and 3, 3, 3, those vectors are going in the same direction, because one's longer than the other. Okay? So, here's a fun application of vectors. Okay? I have 3 coordinates here, and I want to determine if they're collinear. Now, we don't have 3-dimensional slope. We're not going to do that. If we were in 2 dimensions, we could find the slope between 2 points and the slope between the other 2 points and see if they're the same. Okay? Well, with vectors, okay, vectors can kind of be our slope, if you will. If 2 vectors are scalar multiples of each other, that means that we are going in the same direction or opposite directions. So if we have 3 points, and I make a vector, if I make 2 vectors out of these points, if they're going in the same direction or opposite directions, what's going to be true about our 3 points? They're going to be collinear. Or if we have something like this, okay, these are going in opposite directions. If we have 2 vectors from our 3 points that are going in either the same or opposite direction, then they're making a line. Okay? So we have 3 points here, and we want to determine if they're collinear. Okay? We're not going to talk about slope, we're just going to make vectors out of them. It does not matter which 2 you pick for vectors, and in what order you pick them for vectors. Because all that matters is the 2 vectors that you have are going to go in the same or opposite direction. They're going to be scalar multiples of each other. So let's find the vector PQ. Remember, terminal minus initial. What's our first component? Terminal minus initial. Terminal minus initial. Terminal minus initial. Thank you. And then let's look at QR. Terminal minus initial. Terminal minus initial. Let's go back to here.
That's
Terminal minus initial should be a positive 4, right? Terminal minus initial, yes, is -2. Terminal minus initial is are these 2 vectors scalar multiples of each other?
yes.
They are. If we take PQ and we multiply it by -2, then we have the vector QR. Okay? So since they're scalar multiples of each other, yes, they are collinear. What's happening is we have P, Q, R. They're going in opposite directions. But they make a line. Yes.
Two, one. So do we just multiply one of the? I don't know.
Well, you just need to recognize that these are scalar multiples of each other. If I multiply this by -2, it's the same as this.
Okay, so maybe we can multiply.
If you can multiply one vector by a number to get the other vector, you're good to go. But if we have like 1, 1, 1, 2, 2, 3, those are not scalar multiples of each other, and so we wouldn't be going in the same direction. Okay? All right. So here's your homework. Okay. I know that since it's Wednesday, we took a little bit more time than we have to go over homework. You don't have quite the time you had yesterday to work on your homework. Just keep in mind that do what you need to. If there are 5 problems that are the same and after the second one you think you have it, go to the next chunk of problems. Okay? By this time in your math career, you should know if you understand it or not. Okay? But you should at least do 1 problem from every single chunk of problems. Okay? Really, I'm suggesting you do all of these. But if time is an issue, make sure you do at least a couple problems from each chunk. Okay?